In today's video, I am going to solve this problem which has appeared on the Oxford entrance exam. Many students had trouble with solving this. So the problem states if 6 plus f of x is equal to 2 times f of minus x plus 3x squared times an integral from a minus 1 to 1 f of x dx, calculate what is integral from a minus 1 to 1 f of x dx. Let's first note that I is an integral from a minus 1 to 1 f of x dx. Now, when we substitute I in the first equation, we get that 6 plus f of x is equal to 2 times f of minus x plus 3x squared times I. Now, if you take a look, you see that 3x squared appears in this equation, and we know that 3x squared is equal to x to the power 3, and then first derivative of that. So we see that we have a derivative in this position, and we are interested in solving the integral. So let's integrate the entire equation by an integral from a minus 1 to 1 dx. And thus we get the following. An integral from minus 1 to 1, 6 plus f of x dx is equal to an integral from a minus 1 to 1 to f of minus x plus 3x squared times I dx. Now this is going to become an integral from a minus 1 to 1. 6 can get outside of the integral as a constant, and dx remains. Plus a next integral is from a minus 1 to 1 f of x dx, and that is then equal to an integral 2 times an integral from minus 1 to 1 f of minus x dx plus an integral from a minus 1 to 1 3x squared I dx. Now, a little note I would like for this integral in this position. So, an integral from a minus 1 to 1 3x squared I dx is equal to an integral from a minus 1 to 1 3x squared times, and I was an integral from a minus 1 to 1 f of x dx, and then dx. So when we take a look at this integral, it is a bounded integral from minus 1 to 1 of a function f of x dx. That is going to be a real number, a constant, which we have denoted as I. So this is a real number, and as a constant, it can get outside of the integral. So we are going to be left with 3I, an integral from minus 1 to 1, x squared dx. Let's substitute that into our equation, which we are solving. So we get 6, an integral from minus 1 to 1 dx, plus an integral from minus 1 to 1 f of x dx is then equal to 2 times an integral from minus 1 to 1 f of minus x dx plus 3I, an integral from minus 1 to 1 x squared dx. And now let's evaluate this. So we have 6 times x in the bounded from minus 1 to 1 plus an integral from a minus 1 to 1 f of x dx is I. And that is equal to 2 times an integral from minus 1 to 1 f of minus x dx plus 3I times an integral of x squared dx is x cubed divided by 3, and the borders are from minus 1 to 1. So when we calculate this, it becomes 6 times 1 minus minus 1 plus I is equal to 2 times an integral from minus 1 to 1 f of minus x dx plus 3 and 3 are going to cancel out. I is a constant, and x cubed is 1 to the power 3 minus minus 1 to the power 3. So 1 minus minus 1 is equal to 2. and this is 1 minus minus 1. This is again equal to 2. At this point, our equation becomes 12 plus I is equal to 2 times an integral from minus 1 to 1 f of minus x dx plus 2I. Now, we can introduce a substitution in this integral as t is equal to negative x, and then differential respectful of t is equal to negative dx. Now, if x is equal to negative 1, that means that t is equal to 1, and if x is equal to 1, we get that t is equal to negative 1. So our equation then becomes 12 plus I is equal to 2 times an integral from 1 to negative 1. F of minus x is f of t, and dx is negative dt plus 2I. And in this position, because we have a minus in front of a sign of an integral, we can change the borders. So it is 12 plus I, which is equal to 2 times an integral from a minus 1 to 1, f of t dt plus 2I. And this integral, we already know that it is equal to I. So this is 12 plus I is equal to I plus 2I, which is 4I. And that means that 12 is equal to 3I, and that gives us the value of I to be equal to 4. Well, I was an integral for minus 1 to 1 f of x dx, and we got its value at 4. Well, there is another way we can solve this problem, and I am going to show that way now. So we have the equation 6 plus f of x is equal to 2 times f of minus x plus 3x squared I. And that gives us that f of x is equal to negative 6 plus 2f of minus x plus 3x squared times I. Now when we plug in the minus x into this function f, we get that this is minus 6 plus 2 times f of minus x plus 3 minus x squared I. And that is going to give us that f of minus x is equal to negative 6 plus 2f of x plus 3x squared I. Now, if we take this equation and we plug its result into this equation, we are going to get the following. F of x is going to be equal to negative 6 plus 2 times f of minus x is minus 6 plus 2f of x plus 3x squared I, and then plus 3x squared I. And this is going to be equal to negative 6 minus 12 plus 4f of x plus 6x squared I plus 3x squared I. So we have f of x and 4f of x. That is going to become negative 3f of x, which is then going to be equal to minus 6 and 12, that is 18, plus 9x squared I. Well, then f of x is going to become 6 minus 3x squared I. Now, when we continue from this position that f of x is 6 minus 3x squared I, and we integrate this equation from minus 1 to 1 f of x dx equal to an integral from minus 1 to 1 6 minus 3x squared I dx, we are going to get that I is equal to 6 times an integral from 1 to 1 dx minus 3I integral of x squared dx from minus 1 to 1. We know that this is 2, and we know that this integral is 2, and it is going to cancel out with this 3. So I is equal to 12 minus 2I, giving us that 3I is equal to 12. basically I is equal to 4. So another method by which we can solve this problem is to see what is f of x. And that is from this equation going to be negative 6 plus 2f of minus x plus 3x squared I. And then if we plug in the value of minus x into this function f, we get this as minus 6 plus 2 f of x plus 3x squared I. At this point, what we can observe is that f of x is equal to 2f of minus x plus 3x squared I minus 6. And f of minus x is equal to 2f of x plus 3x squared I minus 6. These parts of the equations are the same. So if we subtract one equation from another, we are going to get that f of x minus f of minus x is going to be equal to 2f of minus x minus 2f of x. This is going to give us that f of x minus 2f of minus x minus f of minus x plus 2f of x is equal to 0. F of x and 2f of x is 3f of x minus 2f of minus x and minus f of minus x are minus 3f of minus x, and that is going to be equal to 0. So this equation is then 3 times f of x minus f of minus x is equal to 0, and that means that f of x minus f of minus x is equal to 0. And that basically means that f of x is equal to f of minus x, and that means that f is an even function. Well, what that means is that we can plug this result into our beginning problem, and then it becomes 6 plus f of x is equal to 2 times f of x plus 3x squared I. Well, then 6 minus 3x squared I is equal to 2f of x minus f of x, and that means that f of x is equal to 6 minus 3x squared I. Now, if we integrate this equation from a minus 1 to 1 dx, we are going to get that integral from a minus 1 to 1 f of x dx is equal to an integral from minus 1 to 1 6 minus 3x squared I dx. And this is equal to 6 times an integral from a minus 1 to 1 dx minus 3I, an integral from minus 1 to 1 x squared dx. And we have already valued these integrals at 2, this one, and this one was also 2, but 3 gets cancelled out. So then our integral, this is I, this equation then becomes I is equal to 12 minus 2I, and that means that 3I is equal 12, and that gives us the result of I being equal to 4. Now the third method which I'm going to show as a solution for this problem is the following. We are going to differentiate this equation and we are going to evaluate it at specific points. So by evaluating for x is equal to 0 from the equation which we are given at the beginning, we get that 6 plus f of 0 is going to be 2f of 0 plus 0. And at this point we see that f of 0 has to be equal to number 6. Now we are going to take the equation which we started from. 6 plus f of x is equal to 2 times f of minus x plus 3x squared I, and we are going to differentiate this equation respectful of the x. So we are going to get 0 plus f prime of x is equal to negative 2f prime of x, negative x, and plus 6x and I is a constant, so it gets outside of the differentiation. So by evaluating this equation at x equal to 0, we get that f prime at 0 is equal to negative 2f prime at 0, and this is 0. So we get that 3f prime of 0 is equal to 0, so f prime at 0 has to be equal to 0. Now we are going to take this equation, f prime of x is equal to negative 2f prime of minus x plus 6xi, and we are going to differentiate it respectful of x one more time. So we get that f secundum of x is equal to 2f secundum of negative x plus 6i. By evaluating it at x is equal 0, we get that f secundum at 0 is equal to 2f secundum at 0 plus 6i. This is negative f secundum at 0 is equal 6i, so f at secundum at 0 becomes negative 6i. My bad. Now again, I'm going to take this equation which we got. F secundum of x is equal to 2 times f secundum of minus x plus 6i, and I'm going to differentiate it respectful of x. So at this point I get f third derivative of x is equal to 2 times f third derivative of minus x and minus in front of it, and this goes to 0. So, but by evaluating at x is equal 0, I get that f third derivative at 0 is equal to negative 2 times f third derivative at 0. So 3f third derivatives at 0 are 0, so f third derivative at 0 is 0. Now, it's easy to see that if I take the f third derivative of x is equal to negative 2f third derivative at minus x, and I do another derivative respectful of x, I'm going to get f fourth derivative of x, which is equal to 2f fourth derivative of x, of negative x. And by evaluating at 0, I get f fourth derivative at 0 is equal to 2f fourth derivatives at 0. Basically, I again get that f fourth derivative at 0 is 0. So this 0 is going to repeat again for the fifth derivative, sixth derivative, and all of them. Now, because f third derivative at 0 is 0 and f fourth derivative at 0 is 0, and we already got that f second derivative at 0 is negative 6i, we got the result that f first derivative at 0 is 0, and we got the value of the function f at 0 to be 6. Well, we can see that f of x has to be a polynomial. It has an equation of ax squared plus bx plus c, right? Because this third derivative at 0 is 0, and all the derivatives that come after it all fall to 0. So the problem now becomes just to find the constants a, b, and c. So we know that f at 0 is equal to 6, but if we plug 0 at this first equation, we are going to get that f at 0 is equal to c. So that means that c is equal 6. Now if we take the first derivative of this function, we are going to get it at 2ax plus b. And we know that f first derivative at 0 is going then to be 0b, and f first derivative at 0 is 0. So that means that b is equal to 0. And the third derivative of this function at x, the second derivative of this function at x is going to be 2a, and second derivative at in the point 0 is then going to be 2a, and we know this to be minus 6i. So this means that a is going to be equal to negative 3i. And that means that our function f of x is going to have a formula of a is equal to negative 3i multiplied by x squared, b falls to 0, and c is 6. Now the question becomes just to find the integral. So an integral from minus 1 to 1 f of x dx is then going to be equal to an integral from minus 1 to 1 negative 3i x squared plus 6 dx, which is equal to 6 times an integral from minus 1 to 1 dx minus 3i integral from minus 1 to 1 x squared dx. We know that this integral is equal to 2, and we know that this integral is going to cancel out with these 3 and give us the value of 2. So this is the integral I, so then I becomes equal to 12, 2 times 6 minus 2i. And that means that 3i is equal to 12, and that means that I is equal to 4. Thank you for watching. Please like, share, and subscribe, and I'm looking forward to reading your comments. I'll see you in the next video.